Hello, this is Bunton again with your Visual Functional Mathematics at Level 2, Part 1 on numbers. Today's lesson is Lesson 7 on direct proportions and inverse proportions. I have to warn you that this particular topic is a little bit more complex than the previous ones you've dealt with, especially inverse proportion. But that's why I'm here. I will explain it to you, and if you have any questions, go back, read through the presentation I've done, and if you still have any question, I'll give you my email address to contact me. Here we go. Direct proportions and inverse proportions. In this lesson you will know what direct proportion is, how to use direct proportion, what inverse proportion is, how to use inverse proportion, and how to describe the different characteristics. You will note the arrows and the little icons each of them are pointing to. So you see with the direct proportion, you see the two giraffes. One is a little giraffe, but eventually will grow as the other one has grown, so they are moving in the right direction. With the inverse proportion, you see the little seesaw, and I'm sure all of us as kids, even some of us as grown-ups, have ridden on the seesaw one time or another in our lives, and they tend to go in opposite directions. And of course, the pair of graphs you've seen there will tell you what the characteristics in. Direct proportion is going straight line upwards, while the inverse proportion is curvy and tend to be going downwards. The keywords you will learn are proportion, direct, inverse, scale, and opposite. As a matter of fact, they are not words you will learn because you probably know them already, but you will be using them in the correct context of maths. Direct proportion. You can use proportion to scale up and down. If an amount is directly proportional to another, it means that as one amount increases, the other amount increases at the same time. They're going towards the same direction. This means that if one amount is doubled, then the other amount is doubled as well. You can use proportions to scale things up and down. First, work out the value or amount needed for one thing by dividing, then multiply it to get the value for the number or things you're looking for. I'm sure this will remind you of a topic we just did, which is ratio. With ratio, you have to find the total, you have to find the value of 1, and then you can work out the proportions. So you see how maths topics are related. Let's continue by looking at the example. Example 1 of using proportion to scale up and down. Lucy is making cakes. She finds this recipe for 12 cakes. 150 grams of flour, 75 grams of sugar, 75 grams of margarine, and 3 eggs. Lucy wants to make 20 cakes. How much margarine does she need? First, start by dividing to work out how much margarine is needed for one. The recipe is for 12 cakes, so you need to divide the weight of the margarine by 12. So 75 grams divided by 12 is equal to 6.25 grams. Secondly, multiply the weight of margarine needed for one cake by 20 to find out how much margarine she needs for 20 cakes. And that would be 125 grams. Let's look at example 2 of using proportion to scale up and down. Breakfast cereal contains 0.4 grams of calcium per every 100 grams. How much calcium does a 35-gram serving of the breakfast cereal contain? First, start by dividing to work out how much calcium is in 1 gram of the cereal. There is 0.4 grams of calcium in 100 grams of cereal. So you need to divide 0.4 by 100. You remember our decimals? So we will end up with 0.004. So one decimal place is extended by adding zeros in front of the 4 because we divided by 100. Secondly, multiply your answer by 35 to find out how much calcium is in 35 grams of cereal, and that is 0.004 times 35, which is 0.14 grams. I'm beginning to enjoy this, I hope you are. Example 3. Reese is a baker. He bakes 500 biscuits in 4 hours shifts. How many biscuits can Reese bake in a 6-hour shift? The same principle applies. Start by dividing to work out how many biscuits Reese can bake in 1 hour. He bakes 500 biscuits in 4 hours, so you need to divide 500 by 4, which will give you 125 biscuits. Next, multiply to find how many biscuits Reese can make in 6 hours. And that is 125 times 6, which is equal to 750 biscuits, all things being equal, of course. Practice question, set 1. Freya is making soup. She needs 500 grams of carrots to make 1 liter of soup. How many grams of carrot does she need to make 1.5 liter of soup? Question 2. 1,000 ml of lemonade contains 250 ml of lemon juice. How much lemon juice does 600 ml of lemonade contain? Question 3. Leon runs 10 kilometers in 49 minutes. Assuming he runs at the same speed, how long should it take him to run 18 kilometers? That is, if he doesn't get tired. Question 4. Shrishti collects the following information about train fares and journey distances. And you can see it there. Just read it carefully, study it, and look at the price and look at the journey's distance. She says that the distance of a train journey and the price of the tickets are directly proportional. Is she correct? Explain your answers. And these are the answers. Question 1, 750 grams. Question 2, 150 ml. Question 3, 88.2 minutes to run the distance. And then question 4, no. For example, a ticket that costs £4 is for a distance of 16 kilometers. But a ticket that costs just 3 times more, £12, is not for a distance for 3 times. You remember we're talking about direct proportion. Now let's look at inverse proportion, which is the opposite of direct proportion. If an amount is inversely proportional to another, it means that as one amount increases, the other decreases at the same rate. If you take a look at the icon on the bottom right, you will see what I'm talking about. This means that if one amount is doubled, then the other amount is halved. To work out how a value changes, first you need to multiply to find the value for one thing. Then you need to divide to find the value you're looking for. It can be a little bit confusing, but just concentrate on it and read through as many times as you have to get it. And then, of course, look at the examples. Let's do that now. Example 1 of inverse proportion. 5 people take 12 minutes to change all of the light bulbs in a restaurant. How long would it take 3 people to change all of the light bulbs in the restaurant? So you start by working out how long it would take one person to change the light bulb. If 5 people takes 12 minutes, so you need to multiply 5 by 12 to know how much one person would take. That would be 60 minutes, because there are less people in the job. Now divide to find the time for 3 people. So that is 60 minutes divided by 3, which is 20 minutes. You got it? If you're not sure, go through it again. One person will obviously take longer than it will take 3 people to do the same job. Example 2. 2 people will each have to paint at a rate of 45 meters squared per hour to finish painting a house exactly on schedule. At what rate would 6 people each have to paint to finish exactly on schedule? 1. Start by working out the rate of one person. There are 2 people, so multiply 45 by 2. 2 times 45 is equal to 90 meters squared per hour. Secondly, divide to find the rate of 6 people. So 90 divided by 6 is equal to 15 meters squared per hour, because there are more people doing the job. How many people would be needed so they could paint at a rate of 9 meters square per hour? Divide the rate of one person by the new rate of 9 to find the number of people needed, which is equal to 10 people. Come to think of it, it's not as difficult as I thought it would be, but you need to concentrate and listen carefully. That's why I'm here, to narrate what you have to do. Example 3 of inverse proportion. Peter is making solid balls out of different metals. Listen carefully, this I think is the more complex example. The balls all have the same weight. The volume of each ball is inversely proportional to its density. He makes one ball out of aluminium. Its volume is 108 centimeter cube, or cubic centimeters, and its density is 2.6 grams per cubic centimeters. He used steel to make a new ball with a density of 7.8 grams per cubic centimeters. What is the volume of the steel ball? First, look at how the densities are related. 7.8 divided by 2.6 is equal to 3. So the density of the steel ball is 3 times greater than the density of the aluminium ball. I'll suggest you Google the meaning of density if you're not quite sure. What density means is how compact they are, or something is. Okay, and then secondly, since volume is inversely proportional to density, the volume of the steel ball makes 1/3 of the volume of the aluminium ball. 108 divided by 3 is equal to 36 centimeter cube, or 36 cubic centimeters. Let's look at practice question set 2 based on inverse proportion. Question 1. A call center has 5 people answering calls. To answer all of the calls, each person needs to work at a rate of 14 calls per hour. At what rate would 7 people need to work to answer the same number of calls? Question 2. The time it takes an object to move a certain distance is inversely proportional to the speed that is traveling at. It takes a car 12 minutes to travel the length of a road if it goes at an average speed of 60 miles per hour. How long would it take the car to travel down the same road if it traveled at an average speed of 30 miles per hour? And then B, if it takes the car 36 minutes to drive down the road, what will be its average speed? And these are your answer. Question 1, 10 calls per hour. Question 2, A, 24 minutes, and then B, 20 miles per hour. And then before we go, let's look at what we have covered and how much you've learned. So you now know what direct proportion is. You now know how to use direct proportion to answer questions. You now know that inverse proportion is the opposite of direct proportion. You know how to use inverse proportion method to answer questions. You know how to describe the different characteristics of direct and inverse proportion. You know that to apply both methods, you need to find the value or the rate of 1, and then you apply. It's a short lesson, but you need to give it a little bit more thought. Not that it's more difficult, but it can be a little bit more confusing. We're going deeper into maths now. And that's our lesson for today. It's a little bit more complex than the other topics we've done so far, but that doesn't mean it is difficult. All you have to do is just go through the video again, do all the practice test questions, do them first, then you check your answers and make your corrections. Oh, by the way, don't forget to celebrate. Pat yourself on the back when you get all of them right. That's it. I'll see you next week. Take care of yourselves and thank you. Bye.